Assalamu alaikum. So in this video, we will see how we can work with jobs in Kubernetes. So we saw in the previous video that jobs are a controller in Kubernetes, like deployments and replica sets, stateful sets, and daemon sets. We use them to deploy pods to a Kubernetes cluster. And we use jobs when we want to deploy pods, either to perform a task and then we didn't need those pods anymore. Here we use the type jobs, and we have another type of jobs, and it is called cron jobs, and we use it when we want to perform a task periodically in the cluster. So for example, if you want to do something in your Kubernetes cluster, for example every day at a specific time, here we need to use cron job to deploy pods in the cluster. Okay. In this video we will see how we can work with jobs, and in the next video we will see cron jobs. So first of all, to create a job, we have to write the YAML file to create the job. Okay. So here I will call it, for example, just myjob.yaml. Here, like all the other Kubernetes objects, first of all, we start with the API version. Here, to create a job, the API version must be batch /v1. Okay. So to create a job, we have to use this API version. And then we have the kind, which is the type of the Kubernetes object that we want to create. Here we want to create a job. And then we have the metadata section. Here we will give our job a name. For example, I will call it just count a job. We can give it also some labels, but it is not required. And then we will go to the spec section. And here in the spec section, we have the template where we put the configuration of the pod. So here, for example, if you want to give the pods some labels, you can use the metadata property and here set the labels of the pod. Okay. But for me, I will not give the pods some labels. So here just I will go to the spec of the pod, and here you have the containers property. So here we will create only one container using the image CentOS. I will give the container a name, for example, CentOS container. And then I will use the command property to give the container some commands that should be executed. Okay. So here I will create a CentOS container using the CentOS image, and I want this container to echo the numbers from 1 to 9. Okay. So this is the task that should be performed by this pod. Okay. So here we will use the bash. We want to echo the numbers from 1 to 9. So here we will use this job to create a pod to perform the task. Okay. Writing the number from 1 to 9. Okay. And finally here we have to set the restart policy of the pod. And we will set it to never. Okay, so that's what we have to do here in the YAML file. Here you have to know that the kind should be a job and the API version should be set to patch /v1. Now let's create the job using kubectl create, and then we give it the name of the YAML file, which is myjob.yaml. So here we have create. So here Kubernetes tells us that the job was created. We can verify that using kubectl get jobs, and here we have our job called count job, and here we have the number of completion, the duration of the job, and the age of the job. Okay, so here by default the job will be completed if the pod was created and successfully terminated. Okay, here if we display the pods using kubectl get pods, so here we have pods. We can get more information about the job using kubectl get describe job count job. Then we give it the name of the job. Okay, so here we find the name of the job, the namespace that this job belongs to. Here we have the selector and some labels assigned to this job. Here we have two properties, the parallelism and the completions. We will see those just in a few seconds. Here we see when the job was started and when it is completed, and the duration of the job. And here we find the state of the pods. Okay, so here now we have 0 pod running when pod was succeeded and 0 pod failed. Okay, and here we have the pod template. So here we have the containers, the image used to create this container, and the command given to this container. Okay, so by default the job will create one pod and will be completed if the pod was terminated successfully. Okay, and here we can verify that this task is successfully achieved using the command kubectl logs. So logs, and we see the logs of the pod. Okay, let's first of all get the pods using kubectl get pods. So here is the name of the pod, and now let's see the logs using kubectl logs, and then the name of the pod, which is count job combined with those characters. So here we find the numbers written by the pod. Okay, so here the job will make sure that the pod terminates successfully and then being completed. Okay, so after making sure that the pod created by the job is successfully terminated and it exits with the code 0, then the job will be completed. If an error occurs to the pod, here the job will notices that something goes wrong with the pod and will create another pod. Okay, so here the job will be completed only after making sure that the pod was successfully terminated. Okay, and if something goes wrong with the pod, the job will detect that and will create another pod. So here everything works fine. So when we create the job, a pod was created and the pod writes those numbers from 1 to 9 on the terminal and then terminates, The job detects that the pod successfully terminated, so it goes to the completed state. Here, if we describe the job, here under the reason, we find the state of the job. Okay, so here first of all it is successfully created, so the job was successfully created and the pod is running, and here it is successfully completed. The job goes to the state after making sure that the pod was successfully terminated. Okay, so if we make a typo here, instead of do here I will add another character just to make something wrong here. Now when we create the job using this file, the job will create a pod, but because of this typo here, an error will occur in the pod. Okay, so here the job will notices that something goes wrong with the pod and will try to create another pod. Okay, let's verify that. First of all, let's delete the job using kubectl delete job. So here we have count job, and when we delete the job, all the pods created by this job will be deleted. We can verify that using kubectl get pods. So now after deleting the job, we didn't find any pod running in the cluster. Okay, so now the count job was deleted. Let's now recreate the job after making this typo here. Okay, so here we will use the command kubectl create, and then we give it the name of the YAML file. So now the job was created. We can verify that using kubectl get jobs, and here we have our count job. Okay, let's see the pods created by this job using kubectl get pods. Look, here we find 2 pods created by the job. Here the job create this first pod, okay, with this name, but because something goes wrong with this pod, so an error occurs in the pod, here the job notices that and create another pod to achieve this task. So if the pod created by the job doesn't terminate successfully, here the job will create another pod. Okay, the job will terminate only after making sure that the pod terminates successfully. Okay, but here the same thing occurs with the second pod. So here there is an error in the second pod, and if we list the pods again, here we see that we have 4 pods created by the job. Okay, and by default the job will try to recreate the pod 6 times, and after that, if the last pod doesn't successfully terminate, the job will fail. Okay, so now if we get the pods again, now we have 5 pods. If we describe the job using kubectl describe job count job, so here the pod was successfully created, but there is no pod successfully terminates. Okay, the 5 pods are failed. Okay, so here the job will create another pod, and if the pod number 6 will fails, the job will terminate with the failed state. Okay, but we can override this behavior using the backoffLimit property. Okay, so here using this property, we can tell the job how many pods should be created before it terminates with the failed state. Okay, So for example, here, if we set this property to 2, here the job will create the first pod. If it fails, it will create another pod. If the second pod fails, we'll create a third pod. Here the job will terminate with the failed state. Okay. So here, let's get the pods. Here we have a 6 pod created by the job. And if we get the description of the job, here we find that a 6 pod was created by the job, but no pod was terminated successfully. Okay, let's see how we can override that. So let's first of all delete the job using kubectl delete job count job. We can verify that the pods was deleted. So now we didn't have any pod. Now using this property backoffLimit, we set it to 2. So here the job will create the first pod. If it is successfully terminated, the job will be completed successfully. And if something goes wrong with the first pod, the job will create another pod. If the same thing for the second pod, something goes wrong, here the job will create a third pod, and here the job will terminate with the failed state. Okay, let's verify that. So first of all, let's create the job using kubectl create, and then we give it the name of the YAML file. So now the job was successfully created. Let's get the pods. Here we have this first pod, and here we have an error. So something goes wrong with this pod. The reason of this error is this typo here. Okay. So now let's display the pods again. Now the job create another pod, and the same for the second pod. So something goes wrong here. Now the job will create finally another pod, and here the job will terminate with the failed state. Okay. So now we have 3 pods created by the job, and all the pods are failed. Okay. Now let's get the description of the job using kubectl describe job, and then we give it the name of the job. So here the job failed, and the reason is backoffLimit exceeded. Okay, and here we have this message: job has reached the specified backoffLimit. Another property that we have here is the activeDeadlineSeconds. So here, using this property, we can set the duration of the job. Here the job should be terminated before this duration. Okay. If this duration is reached and the job still active, here the job will fails with the reason deadline exceeded. Okay. So using this property, we tell the job that it should be terminated before this duration. Okay. So here, let's remove this property and remove the reason of those errors, which is this typo here. And here we will set the property active deadline seconds. So let's set this property, for example, to 20, and we will keep the typo here just to make an error in the pod. Here, if the job doesn't terminate after 20 seconds, the job will fail with the reason deadline exceeded. Okay, let's verify that. So first of all, let's create the job using kubectl create, and then we give it the name of the job, the name of the YAML file. So now if we list the pod created by the job using kubectl get pods, here we have one pod created. Now the job start another pod, but it will fails because it doesn't terminate after 20 seconds. Now if we get the description of the job using kubectl describe job, and we give it the name of the job, here we have the deadline exceeded reason. So the job was failed because of this reason, okay, because it doesn't terminate after 20 seconds. Okay, and here we see this message, the job was active longer than specified deadline. So using this property, we tell the job that it should be terminated before 20 seconds. If we reach the duration of 20 seconds and the job still active, here the job will fail with the reason deadline exceeded. Okay, and if we go here, we find two properties. We have here the property parallelism, and here we have the completions property. We can set this property to tell the job how many pods should be successfully terminated. Okay, by default this property has the value of 1, but we can override this property. So here we can set the completions property, and here we give it the number of pods that should be successfully terminated before the completion of the job. Okay, so here if we set, for example, this property to 5, here the job will create 5 pods, and it will ensure that all the pods are successfully terminated, and then the job will be successfully completed. Okay, so by default the job will create 1 pod, but we can override that using the completions property. So here let's first of all delete the job. So now we didn't have any pod in the cluster. Now let's create the job using this updated file. So kubectl create, and we give it the name of the YAML file. So now the job was created. If we get the pods, so here the job create this first pod, and it is successfully completed, and then it create this second pod. Now it is in the container creating state. So the job here will be successfully completed after making sure that 5 pods are created and successfully terminated. So if we list the pods again, here we find 5 pods created by the job, and all of them are successfully completed. Okay, and we can verify that using kubectl describe job. So here the job was completed, and here we find the job was completed. So the job was successfully completed. And if we go here to see the state of the pods, here we find no pod is running and no pod failed, and here we have 5 pods successfully terminated. Okay, Another property we have here is the parallelism property. Here, using this property, we tell the job how many pods can be created and running at the same time. Okay. By default, the parallelism has the value of 1, but we can set this property here. So for example, if we set this property to 2, here the job will first of all create 2 pods, and after that, after making sure that the pods are successfully terminated, he will create 2 other pods, and after that the job will create the 5th pod. Okay, so using this property, we tell the job how many pods can be created and running at the same time. Okay, so if we delete this job and we create it again after setting the parallelism property, now if we list the pods using kubectl get pods, here we find that 2 pods are created at the same time by the job. Okay, but previously when we work with the default value, which is 1, here the job creates the pods one by one. Okay, but now after setting this property, now the job creates 2 pods at the same time. And if we list the pods again, so after making sure that these 2 pods are successfully terminated, here the job creates 2 other pods, these 2 pods, and finally, because here we have 5, it creates this pod. Okay, so here with the completions property, we tell the job how many pods should be successfully terminated, and with the parallelism property, we tell the job how many pods can be created and running at the same time. Okay, and finally, you have to know that by deleting the job, the pods created by this job will be deleted. Okay, so you don't have to delete the pods one by one, just delete the job using kubectl delete job, and we give it the name of the job, and by deleting the job, all the pods created by this job will be deleted. Okay, so if we list the pods, we didn't have any pod in the cluster. Okay, so that's it for this video. In the next one, we will see cron jobs, and finally, I hope that everything is clear, and thank you very much.